Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
So today we are going to talk about electronic configurations of atom. Electronic configurations of an atom show how electrons are filled in the orbitals, and it describes the arrangements of an electrons in the atom. There are two basic rules when we write the electronic configuration. But before I go into the first rule, which is known as the Aufbau rule, I will need you to practice on writing the filling order, which is 1s, 2s, 3s, 4s, 5s. Up to 5s orbital is good enough. So followed by 2p, 3p, 4p, 5p, 3d, 4d, 5d, 4f, 5f. Alright, so this is what we meant by the filling order. So how does it work? Now we'll look at this rule, the Aufbau principle. According to Aufbau principle, electrons in an atom should be filled in the orbital in the order of increasing energy level. So how am I going to write out this? Okay, it is from here, the filling order. So you see, first of all, you're going to pass through 1s. Means to say that the 1s orbital is the one with lowest energy, followed by 2s. Okay, as you can see, 1s followed by 2s, followed by, okay, you can see the arrow will pass through the 2p first, okay, followed by 3s. So you can see 1s, 2s, 2p followed by 3s. Okay, so you draw the arrow again, it is going to be followed by 3p, right? Then 4s, okay, and then continue on. You're going to have your 3d, 4p, 5s, and so on. Okay, so this is what we call the filling order, and the order of orbital will be filled according to the increasing energy level. Okay, and right now you need to know that for s orbital, the maximum electrons that can fill in this orbital is 2. Whereas for p orbital, the maximum it can go is 6 electron. And d orbital, maximum it can go is 10 electron. So I'm not going to touch about f orbital since it's not in our syllabus. Alright, now let's look at this example. For the carbon having 6 electrons, okay, so I'm going to write it out like that according to the Aufbau principle. 1s, okay, 1s, s maximum can have 2 electrons, so it will be 1s2, okay, followed by 2s. 2s maximum can fill up 2 electrons, okay, and then continue with 2p. So I'm going to write my 2p here. So now you have used up 4 electrons. You need 6 electrons, means you have 2 electrons left. So then you have to write 2 over here. The next rule we're going to talk about is the Hunch rule. When filling up a subshell, each orbital must be occupied singly first, meaning we have to keep the electron spins the same before filling up in pair. Alright, so for example, nitrogen having a total of 7 electrons because it has 7 proton. So this is how we write nitrogen's configuration: 1s2, 2s2, and 2p3. Okay, so if you add up 2 plus 2 plus 3 equals to 7. Okay, now how are we going to show the Hunch rule? Okay, we have to show out the orbital. This is 1s, this is 2s, this is 2p. So according to the Hunt rule, when we want to fill electrons, we have to make sure that it fills singly first in the same shell. So 1s is one shell, so we have to fill up the 2 electrons, so this is 1 and 2, followed by 2 electrons here. But for p electrons, because p electrons has 3 subshell, okay, the p orbital has 3 subshell, therefore we have to fill up the configuration like this, 1, 2, 3, by keeping electron spin the same first. Means we have to fill up this part before we put it in pair. All right, now we'll see one more example. For oxygen, this is how we write the electronic configuration. We start with 1s2, 2s2 followed by 2p4. Okay, 2 plus 2 plus 4 equals to 8 electrons. All right, so now if we look at this rule, this is 1s, 2s, and 2p. 2 electrons is filled, followed by the 2 electron is filled. But when it comes to 2p4 electrons, we have to fill up the electrons singly first before we pair it up. So you will have 1, 2, 3, and 4 electrons. So this is how we fill. All right. So I've introduced you both Aufbau rule and principle. Now we look at the special notes here. Electrons occupy the 4s orbital first before filling up the 3d orbitals. Once the 3d orbitals are occupied by electrons, this will repel the 4s to a slightly higher energy level. It means that according to the Aufbau principle that I've mentioned, you can see that 4s orbital is filled up first, followed by 3d. It means that the 4s orbital having a slightly lower energy compared to 3d. So for this side, whenever you have 4s orbital, okay, that is filled, let's say 4s2, okay, is filled, followed by 3d. As long as this 1 electrons in the 3d orbital start appearing, this electron is going to repel this 2 electrons from the 4s orbital to a slightly higher energy level, which means once this electron is filled, the 4s orbital no longer be the lower energy. It becomes the higher energy because it's being repelled by the electrons in the 3d. So therefore, you will have this situation. So why is this situation is important? Because whenever 4s orbital being repelled to the higher energy level, it also become the outer electrons. So when we want to form ions, we are going to remove electrons from the 4s orbital first. All right, now we can see example later. All right, now this is the example. If let's say we have boron having 5 protons, 5 proton means it has 5 electrons. So we have to practice on writing the electronic configuration according to the Aufbau rule and the Hunt rule that we have just learned. Okay, so it always starts with 1s, 2s, 1s2, 2s2, and 2p1. So you can see total of 5 electrons. All right, so if you want to draw it out, it would be like this: 1s, 2s, and 2p, 1, 2, 3, 4, and 5. Okay, so for neon, it is 1s2, 2s2, and 2p, 6. As I mentioned before, 6 is the maximum electrons that can be filled in the p orbital. So if you add up 2 plus 2 plus 6, it will be equals to 10. All right, so the sequence of filling the orbitals will be like this: 1s, 2s, and 2p. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So the next example will be magnesium. Magnesium having 12 electrons, so it will be 1s2, 2s2, 2p6, and 3s2. Okay, so how do we fill up the configuration? So this is 1s, 2s, 2p, and then followed by 3s. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So for magnesium, 2 plus means that from this configurations, 2 electrons are removed. So we're going to remove the electrons from the outer orbital, which is the 3s2. So therefore, it left with 1s2, 2s2, 2p6. All right. Whereas for phosphorus, it has 15 electrons, so it will be 1s2, 2s2, 2p6, 3s2, followed by 3p3. So you add up all this value, it will be equal to the total of 15. Okay, now when it comes to this, okay, some students will find that, oh, it is a bit too long to write out this configuration. We can use short form like this. Okay, so remember, the short form can only take the group 18 or group 0 elements, which is, for example, neon. We know that neon has a total of 10 electrons. So this is how we write the configuration for neon, right? So therefore, we can write this as neon followed by 3s2 and 3p3. Because this whole thing here represent electronic configurations of neon. So you can do it like that. It will be similar to this. Okay? Right. The next thing. For chlorine that has removed 1 electron, they have gained 1 electrons to become chloride. So right now, we're going to write the electronic configurations of the chlorine first. Okay? The Cl, which is having the 17 electron. It will be 1s2, 2s2, 2p6, 3s2, 3p5. So altogether, you're going to have 17 electrons. But this is the configurations of Cl. But if you want to write the configuration of Cl minus, it means that it has gained 1 electron. So therefore, it should be 3p6 because it has gained 1 electrons. All right? Now, the next things will be slightly challenging. For titanium 2 plus, all right, the most common mistake made by students is they're going to do things like that. Titanium 2 plus, they thought that they have total of 22 electrons and 2 electrons is removed, so they thought that, oh, okay, now I need to write 20 electrons. So a lot of students is going to do this form. 1s2, 2s2, 2p6, 3s2, 3p6. Right now you will have a total of 18 followed by 4s2. So then it will mix up 20. But this is a wrong electronic configurations of titanium 2 plus. Why is that so? Because when we want to write electronic configurations of transitions elements, okay, we have to take into account of this concept that I have just explained. Okay, so therefore this whole thing is wrong. So in order to correct this thing, what we need to do is to write out the electronic configurations of titanium atom first. That will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d2. That will make up a total of 22 electrons. Okay, now I've mentioned that whenever 4s orbital started to fill up, followed by 3d orbital started to fill up, so you can see that there are 2 electrons in the 3d2. So once the 3d2 electrons started to fill up, these electrons here will repel the 4s orbital to a slightly higher energy level like this. So when we want to remove electron, because right now we're going to write titanium 2 plus, means we're going to remove the 2 electrons. The 2 electrons should be removed from the 4s orbital. So therefore, the correct configurations of titanium 2 plus is going to be like this: 1s2, 2s2, 2p6, 3s2, 3p6, followed by 3d2. Okay? Same case. Okay? If you notice that vanadium 3 plus, this is coming from the transitions element, we are going to write the configuration of their atom first. We have to start from vanadium 23. So that will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d3. Alright? So now we will need to remove a total of 3 electrons. Okay, so the first 2 electrons is going to be removed from the 4s orbital. So we remove 2 electrons from here, and then we cut 1 electron from here, so left with 2. So therefore, the whole configurations of vanadium 3 plus will be 1s2, 2s2, 2p6, 3s2, 3p6, followed by 3d2. It will be the same as the titanium 2 plus. Alright?
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.